Okay, this video is about photosynthesis and how to balance the chemical equation for it. So in a chemical equation, we have inputs and we have outputs. We have things that we put into it, it's like ingredients, and then we have the product. Okay, so I'm gonna actually go ahead and list that on the board. So we have our inputs, and then those inputs yield the product. So the symbol for yield is an arrow like that, okay? And that yields the outputs, okay? So whenever I ask these questions, what you can do is pause the video and see if you can think of them. So what I want you to do right now is pause the video and think of what are the inputs of photosynthesis and what are the outputs. And then don't play it again until you're ready. Okay, so here we go. Inputs, let's see if you got them right. We have CO2, that's carbon dioxide, okay? That marker isn't very good. I'll try another. Oh, much better, CO2. What else? What other inputs do we have? We have water. Wow. H2O, right? And then we have an energy input, which of course is sunlight, but this is a chemical equation, so we don't put that into the chemical formula. We just make a mental note, or you could say, hey, we also have energy in the form of sunlight, something like that. Just kind of remember that that's there. So that yields something. What does it yield? Hopefully you got this one right. We have glucose. The whole point of photosynthesis is for plants to create their own food from sunlight energy, carbon dioxide, and water. So what is glucose chemically? It's C6H12O6. And hopefully somebody remembered that there's also a happy byproduct from the process of photosynthesis, and that's oxygen in the breathable form, which is O2. So there you have it. You've got your inputs and your outputs. But you might notice that this is impossible. It's totally impossible as it's shown here. This is the simplified version of, hey, these are the basic components you're putting in, this is the basic products you're getting out, but it's not possible as is written here. Let me show you why. Or you could pause it and discuss why it's impossible. You can do that. Or not. Or you can't. Or maybe you just got back. So, you have, this is a molecule. I'm going to use different colors here too. CO2 is a molecule. And if you remember from earlier this year, a molecule is just a smashing together, a bonding group of atoms, okay? So within that molecule of CO2, we have one atom of carbon, and we have two atoms of oxygen bonded together, okay? Here we have another molecule. This one's a molecule of water. Each water molecule has two hydrogen atoms and one oxygen atom. Over here we have two more molecules. One molecule of glucose with 6 carbon atoms each, 12 hydrogen atoms each, and 6 oxygen atoms for each glucose molecule. And then we have an oxygen molecule made up of 2 oxygen atoms, okay? So you can see what's wrong here. For example, we have just one carbon atom on this side of the equation. If it's an equation, chemical equation, you should have the same number, an equal number of carbon on each side of the equation. We have 1 over here, and we have 6 over here. That's a problem. We also have 2 oxygens here, plus 1 equals 3, and we have 2 and 6 over here, that's 8. Doesn't match. Hydrogen, we've got 2 over here, and we have 12 over here. So what does that mean? It means that this is just for looks. This is just as a reminder of, hey, what is photosynthesis in the basic form? But if you want to know how much it actually takes to make one of these, okay, to make one glucose molecule, you've got to change up the numbers. And what you might think you can do is just change these numbers here, okay? Or these numbers over here so they match, but then you're changing the molecules themselves. So you can't change the molecule because then it's not going to be photosynthesis anymore. Photosynthesis is carbon dioxide and water converted into glucose and O2. So it has to stay that or it won't be photosynthesis anymore. But what you can do is figure out how many carbon dioxide molecules does it take, how many water molecules does it take to make how many glucose molecules and how many O2 molecules, okay? So that's what balancing the equation is all about, is just figuring out exactly what are the ratios, what are the proportions of input to output for each molecule, okay? So let's get started. You could start in any different point, okay? So let's just pick one. Maybe we'll get lucky on the first try. It's been over a year since I did this, so let's see if I remember the easiest way. You could just pick out something and say, okay, well, I need 6 carbon atoms on this side to match the 6 I have here. Because I'd like to leave this glucose molecule alone if I can, because it's the biggest molecule, okay? So what I can do then is just say, well, if I need 6 carbon atoms, and there's 1 carbon atom per CO2 molecule, I could say, you know what, I'm going to say there's 6 of those CO2 molecules. Now I've got 12 carbon atoms over here. Oops. No, it's 6. Man, just like in class, I make goofs on the video, and I'm too lazy to redo the whole video, so we'll just leave it in there. So 6 and 6. Sweet. Now what? I've got 12 hydrogens over here, and I only have 2 there. So let's just throw a 6 in front of the water. So now I'd have 12 hydrogen here, because 6 times 2 is 12. And I already had 12 hydrogen over here. So now carbon and hydrogen match on both sides. All right. But while we're messing with the carbon over here, we're also messing with the oxygen. So 6 times 2 is 12. So we have 12 there, plus we have another 6, because 6 times 1 is 6. So we have 18. Boy, that's not showing up very well. There we go. So we have 18 oxygen atoms over on this side of the equation now as inputs. And how many do we have here? We have 6 part of glucose and then an extra 2. So 8, and we need 18, okay? So we need to increase it by 8, right? So what would happen? What do I need to put in front of the oxygen to make it 18? I want to say it was 6. So if I have, for oxygen on this side, I have 6 here, and 6 times 2 is 12. There I've got my 18. Okay? So I think I hit it on the nose on the first try. Yay me. I don't think there's an easier way to start. If you start messing around with this one first, it just becomes complicated and you start trying numbers. But that's the gist of it, okay? So to balance an equation, you're just trying to make sure you have the same number of each input atom type as you have output atom type. And because you have a chemical reaction going on, they're going to be in a different form at the end. So over here I've got oxygen in the form of carbon dioxide and water. Over here I have oxygen by itself in an oxygen molecule, but I also have some in the form of that glucose molecule. Same thing with the carbon. Over here it's in carbon dioxide, over here it's in my glucose. Hydrogen is in my water, now it's in my glucose. But I have the same bits on each side. Okay? Kind of goes to that whole preservation of matter rule. I can't create or destroy in a chemical reaction. I can't create or destroy atoms. Can't do it. So I need to have at the beginning the same stuff that I have at the end. If you have any questions, please ask them.